All right, so now we're gonna hit a 6.5, which is gonna be on graphing tangent and cotangent. MF. I hear it before I see the light shift. Makes a slight, like the electronic powering down for some reason. Firing it back up. All right, so we kind of need to know where our points are here. So like, what did we do for sine and cosine? I'm gonna put in like, we're gonna make a little table real quick. And I'm gonna leave some space between 0, pi over 2. Kind of make a big table here. Pi, 3 pi over 2, and 2 pi. And then I'm gonna make a column for sine, a column for cosine, and then a column for tangent and cotangent. What is sine of 0? 0. Sine pi over 2. This is following the sine graph, so we start middle, go high, go back to middle, go low, go back to middle. Cosine started high, so it starts at 1 and it went downward and then rose back up. So if I look at tangent theta, it's sine over cosine. 0 over 1 is 0. Sine over cosine for pi over 2, 1 over 0 is undefined. This is going to be an asymptote. If I do tangent, I've got 0 over -1, which is 0. -1 over 0 is an asymptote. And 0 over 1 is 0 again. We got either 0 or an asymptote. That's not a whole lot to work with on a graph. So the points we have for tangent and cotangent, we need to expand. I'm going to include negative pi over 2 as well. Negative pi over 2 goes backwards, and it is -1 and 0. So we've kind of got an undefined there too, or an asymptote there. And before we add to it, let's look at our cotangents. Cotangent just flips what we just had. So this will be 1 over 0. This is 0 over 1. -1 over 0. 0 over -1. 1 over 0. 0 over -1. Some of these are zeros. And some of these are asymptotes. So rather than doing like pi over 3, pi over 2, pi over 6 and shit like that. We're just gonna look at the pi over 4s in between. Let's do pi over 4, let's do 3 pi over 4. Let's do. 5 pi, brain farted, 5 pi over 4 and 7 pi over 4. And I'm gonna do negative pi over 4 going the other direction real quick. All of these are the same reference angle. So as soon as we do the pi over 4, we just take a look at the signs and deal with the rest. What is sine of pi over 4?
Is that square root of 2/2?
It is square root of 2/2. Maybe I am your favorite teacher. What about cosine?
Same.
It's the same. The only thing that changes for 3 pi over 4 is the cosine's negative. 5 pi over 4, they're both negative. 7 pi over 4. Sine is negative, but cosine isn't. And if I do negative pi over 4, that's the same as 7 pi over 4. So what is tangent? Pi over 4. I got one thing divided by its exact self, just 1, right? And cotangent is just that flipped over, flip a 1 over, you get 1/1 again, it's still just 1. What about 3 pi over 4? -1. These are all gonna be 1s, we just need to decide if it's positive or negative. And for that, we just count the number of negative signs. 5 pi over 4 is gonna be positive, because there's 2 negatives, they cancel. 7 pi over 4 is gonna be negative. And that means negative pi over 4 is gonna be negative. So let's take a look at what that does to a tangent graph. Let me do tangent first. Everyone's got the table forward. While you're writing, next week, we're gonna do a review. And we're gonna start chapter 6, that way the test will be the Monday after, that way you have a full, like, in the end of the weekend after that. I hate doing testing on Thursdays, it's like, I'd rather give you a week, extra weekend to add that study time. But I want the review day in there. So we're gonna do a review one day, and we're gonna start chapter 7. The next day, which order do you guys wanna do it? Who wants to have the review on Tuesday versus the review on Thursday? Tuesday first, who wants Tuesday? Who wants Thursday? You just got gunned down like fucking Brooke just took a headshot. You like fucking had her hand up for Tuesday, she looked around, she's like, oh, this isn't going well for me. Yeah, speak, you gotta, don't fucking change your mind, look around and say, Dad, don't do that. Don't go by based on what everybody else says. You gotta vote what you want. but I am still gonna go with majority. So we'll do the review on Thursday and we'll start chapter 6 on Tuesday, 7 on Tuesday. You're not gonna like chapter 7. You might say, I don't like it now. Wait till you see chapter 7. Chapter 7 is the hardest chapter in this stuff. And I'm gonna try to make it as easy as possible. I'm gonna try to explain why is the big part. But like still, it's the curve wrecker, score wrecker. Alright, let's do tangent, graphing tangent theta. We saw that every pi over 4 seemed to matter, so that's what we're gonna do. So I'm gonna do like my spacing for like going to a full 2 pi. And then each little like small line will be a pi over 4 mark kind of thing. Tiny marks in between. That is our tangent column. At 0, we had, I'm gonna put down the 1 for the vertical. Let's just do our zeros and asymptotes first. At 0 pi and 2 pi, I have zeros. And it looks like negative pi if I go back. It looks like every pi I'm getting a 0. And all the ones with a pi over 2 in them, we have asymptotes. Now let's go in and fill in our other ones. Pi over 4 was a 1. 3 pi over 4 was negative 1. 5 pi over 4 is positive 1. It's gonna follow this cycle where it starts low and goes high between asymptotes. Which means it's gonna do that going the other direction too. You all remember what x cubed looks like?
How will it?
Y equals x cubed does some shit like this. So does tangent. If you do the pi over 3 and pi over 6's, you'll see that that's how it does it. It throws in some more points for you, but you get weird decimal shit. And as long as you remember it does this curvy shit and it keeps doing it. Yeah, those. Everywhere that we had a 1 over 0 is undefined, and that's where an asymptote is gonna be. So it's basically where cosine is 0. Cause cosine's on bottom for tangent. So if cosine is 0 and cosine is 0. At the pi over 2 mark, pi over 2, 3 pi over 2. 5 pi over 2, negative pi over 2. What's the period here? How often does this graph repeat? It's every pi, right? So the period is half the sine and cosine.
Tan and cotangent period is half.
Yes, cotangent is gonna have a period of. Pi also, this applies to tangent theta and cotangent theta. As we'll see when we graph cotangent theta next. Every other thing we did stays the fucking same. You divide by b to find out where your little, like your. Basically, rather than the 5 points going from 0 to 2 pi now. The base graph we tend to treat for this. As this region right here, we tend to look at negative pi over 2 to pi over 2 for tangent theta. Because it's the values that are closest to 0. To x equals 0. But when you're doing it, divide by b. That tells you how many, we basically have 5 steps here. Undefined. -1, 0, 1, and undefined. We still have 5 steps, it's just over a period of pi rather than 2 pi. Your horizontal shift, your vertical shifts are all calculated the same way. Your amplitude really only changes where this 1 and -1 are. 0 still stays the same, but if we have like a 2, this just goes up to a 2. It's steeper kind of thing. If it's 1/2, it flattens it, but it's still the same shape. Let's take a look at doing cotangent right below it, because it's kind of handy. I'm gonna line up my y-axis right where my y-axis was above. And I'm gonna put in the same marks. So I got a mark there. Throw in our 1 and our -1. For cotangent, sine is on bottom, so everywhere sine is 0. Cotangent blows up. And we can see that's every pi, 0, pi, 2 pi. We actually have our base graph has an asymptote for the y-axis. And every pi after that. At all of our pi over 2 increments, we had, oh, I'm missing the one right there. We had pi over 2, we had. Let's see, we had a 0 here. All of these are zeros. Pi over 2 mark. At pi over 4, we had a 1, and at 3 pi over 4, we have a -1. It looks like between the asymptotes, it's going downward now, 3 dots. Strong, David.
Yeah, I'm just trying to wrap my head around how to see, we built the table and then that's how you're plotting these points. Okay, I just got that.
These are the y values. The x values are over to the left. X values are here, Y values are here,
X value is on top.
are the angles.
Have to do the inverse.
So X or theta.
So I go like theta down to pi and across is for cotangents and asymptote. So we have asymptote and pi.
And now it does the same shit that. Tangent does with the curvy nature. But it does a curve towards the asymptote. So that's gonna do that, and that's gonna do that. So it's kind of curving the other way. The way I remember where the asymptotes are, the asymptotes guide my entire thing for. I didn't write cotangent here. Cotangent theta or cotangent x equals y. That was y equals tangent. I don't know if this helped you. It helped me learn it. You're just gonna have to remember the period is every pi rather than 2 pi. But tangent is sine over cosine. This when the bottom is 0, we have an asymptote. And cosine for on our unit circle. Cosine is 0 up here. And down here. So pi over 2, 3 pi over 2. Negative pi over 2. You're doing every pi over 2 that's not like a even number on top. So every odd pi over 2. Is an asymptote for the base graph. Cotangent is cosine over sine. And again, 0 on bottom equals an asymptote. And if you remember your unit circle well with sine cosine. This occurs at every even. Pi over 2. Zero pi over 2, 2 pi over 2, which is just pi. 4 pi over 2, which is just 2 pi. And same thing going the other direction, shit like that. We'll have a negative pi in there. 0 is obviously in there, that's right there, 0 pi over 2. Negative pi, negative 2 pi. Tangent, when I say odd, I'm saying 1 pi over 2, 3 pi over 2. 5 pi over 2. Negative pi over 2, same thing with your numbers on top being odd. That's where the asymptotes are, and you just gotta remember the wavy nature of tangent, cotangent. If it helps. Do the pi over 4 and the 3 pi over 4, or whichever ones are relevant. For tangent, negative pi over 4 and pi over 4 are the ones closest. And for this one, you want it, for cotangent, you wanna do pi over 4 and 3 pi over 4. For tangent, the base period. Is, both of them is pi, but this is from negative pi over 2 to pi over 2. And for cotangent. The base period is pi, but it's 0 to pi. It repeats every, they both repeat every pi. If you remember these. If you remember this setup, these tell you where the asymptotes are. Right? Negative pi over 2, pi over 2. Negative pi over 2, pi over 2. They tell you where the asymptotes are. And you use every, since it's a period of pi, it repeats every pi. Just add pi to it each direction to keep doing more asymptotes. Go big or go home? You guys just wanna fucking just go to the guns?
Sure.
If you do the hardest one possible in here, everything on homework and tests will be easier. So what did I do last time? Last time we had a negative amplitude. So we're gonna throw in, we want a negative amplitude, let's go with. Y equals -2. Tangent. I don't know, let's do 3x plus pi over 4 minus 1. Things first, factor out that b. If I factor out the b, what am I gonna have on bottom? Well. What will my period be? Pi over 3. It's gonna be pi over b, which is pi over 3. If I do this in increments of 12, which would be handy because this is in 12. That's the same thing as 4 pi over 12. That way I've got it in the same base that this is in. How big is each step? We're doing a full cycle in pi over 3. If we want to break that up into where we have 2 asymptotes on the end, we want to divide it by 4. Which conveniently means each step will be pi over 12. Just like we did with the other one, we're gonna multiply by 1/4. Each step is pi over 12. So I'm gonna draw the base graph of tangent. Let's do, we want pi over 12 as our steps. So 1, 2, I'm just gonna mark that these are in steps of pi over 12. Do a few. I'm not gonna throw down a bunch of asymptotes early because that's gonna be confusing. So the base graph has a 0 at pi. And we're shifting this one left, right? Left or right? Left. So left pi over 2. So my real 0 is gonna be here. I have designed this by making this steps of pi over 12. I just gotta count 2 in each direction and do an asymptote. 1, 2, asymptote. 1, 2, asymptote. And every 2 alternates either a 0 or an asymptote. That's the base graph shifted horizontally. Tangent went like this. So my points are gonna go like that. Oh, wait. Oh, but the negative flips it over, right? The negative is gonna flip it over. So we're gonna have it going like that. So I'm gonna have like, if I flipped it, it would look like this. And I'm not gonna pencil it in, I'm just putting in the dots. This is upside down because we got the -2 in there. So we did our phase shift. Which is our left, right. On our new period. So with our new period. Mark points for amplitude. C, we're going to adjust those points. For vertical shift. Which in this case means moving them all down 1, right? And now I'm gonna connect those. Check. Going towards the asymptotes, but kind of doing a change in the curve at the middle point. Should look a little more curvy than I did. So a pro tip for this is. Do it by hand first. Get that practice in. Pro tips. Throw it in Desmos to see what it looks like. After you do it by hand. To verify you did it right. And then, like plug it in the Homer. Not everyone is doing the. My math lab one, some people are doing the open trigonometry one, so like. Throwing in Desmos will show you the graphing things correct that way. But you want to do it by hand. You guys want another one real quick? Take a look at cotangent maybe? I know, talking a lot, right? See this. What happens if I factor out that, I got a lot of 1/2s in there, fuck it. It's whatever I did, we'll roll with it. What happens if I factor out that 1/2? What? It's x minus pi. You wanna verify it, multiply it back in, you'll see you get pi over 2 when you multiply the 1/2. So what's our period now? Pi over b is pi over 1/2. Which is. 2 pi. Cotangent has sine on bottom. The base zeros are even pies. Or base asymptotes. N pi. And we're shifting by a pi, so that doesn't even change it, does it? Our period is, well. I don't wanna say n pi because we have that shift here. But the base asymptote was 0 and pi. And now it's gonna be 0 and 2 pi. So I'm gonna draw my y axis as a dashed line because it's an asymptote. Would be 2 pi. Which is the sign for our repeat. This is my y axis. Both tangent and cotangent have 3 points between. The asymptotes, so I'm putting 3 lines between the asymptotes. The middle one is a 0. Or both of them. Both tangent and cotangent, the middle of the 3 flat. Slashes is 0. I need to have a vertical component here, this goes up to 1/2. And cotangent went downward from left to right. So we got a mark there and a mark there. Mark there and mark there. This is 3 pi, this is pi. 0. Negative pi. Negative 2 pi. Put those over there too. Now we gotta do a vertical shift of 1, which means going. Up 1 up to 3/2 there. All the points go up 1. There's a lot going on. This is. Just like anything that you get good at, this is gonna just take some practice. You have 2 full weekends before the test. And I will be at the Mesa Center on both Saturdays if you come in, Gerard is there every time, no half company. Well, I assume he's gonna be there, he's been there every time so far. Cotangent goes down from left to right, so will this. Cause the amplitude is positive, it's gonna not flip over, it's gonna do the same thing. That's this in a nutshell. You've seen the graphs of all 6 trig functions now. Have we really done a whole lot else? What else have we done in this chapter? We gotta memorize the unit circle, both degrees and radians.
It's
We did arc length, right? S equals r theta. We did the area of a sector.
The velocity,
I think so.
maybe.
Yeah, angular momentum and angular, or not momentum. Linear speed and angular speed, I think was in this section, I think. And then we get these graphs. That's it, that will be what's on the test. I'm done. Read GTFO. We got questions, ask, like I still got 5 more minutes.
we're trying to understand everything while simultaneously not knowing what's going on at the same
Right?
time.
I realize there's a lot going on, but like, hopefully with you missed Tuesday, but.
Well, it's achievable, it's just.
Yeah, it's achievable, if you're paying, if you were here and you tried to do some of the homework each time. Hopefully the secant and cosecant wasn't too bad, that didn't really up it a whole lot, just tangent, cotangent is a little bit different.
Yeah, I just need like, go on and study it, I'm not
Yeah,
worried.
this is practice, it's just practice,
Yeah.
if you practice this shit, you'll be fine.
So we'll have this one next week, right?
Following Monday, Tuesday. Yeah.
You're not the fourth, right? The fourth of-
Yeah, I need to change the looks.
Double check what time you go to Mesa Center?
I'll be on the Mesa Center from 8 AM to 2 PM on Saturdays.
Okay.
See you then.
Yeah, I'll see you then. Come on in, if you're free on Saturday, come on in.
Probably not this Saturday, but the Saturday after.
Rose Nest, I'll probably be there.
That works.
See you.
See you.
And for homework, what else did we do, like, these type of problems on? Just,
If you want. You have Pearson.
yeah,
If you wanna do more practice problems, you could just click do twice on the question. Or you can go to opentrigonometry.com. I have a link in the announcement that says the free version of homework kind of thing. Go to the announcements, you'll find it, there's a link there. They have a bunch of problems where they give the problem, and then there's, for a lot of them, a short video on. Like try to do the problem on your own and then do a short, look at the short video, see how it's done.
and then would you say going to the, what is it? Math one?
The math lab is a great spot to. Hell, do homework. If you're doing your homework in the math lab center, anytime you have a question, all you gotta do is raise your hand. Or you can try your homework at home and then just save questions and come and ask them.
Yeah,
But you're better off. If you've got the time doing it in the math center, math lab.
cause I feel like I've gone to the math part, but sometimes, sometimes they'll be like I need to look through the. You know how Pearson's like it walks you through like similar problems?
Yeah,
Like they'll look through it and then try to do it
Well-
like how they do it. And like try to piece out from there.
sometimes it's been a while for them.
Yeah,
Not everything comes up all the time, so like if you haven't done something for a while,
yeah.
you're a little rusty at it. Are you going into Larry or Visalia?
By self, for anybody you would like recommend.
John's there all the time,
Okay,
his hair is tall. He's tall, lanky, his hair is short now. He used to have long, his hair was down to his ass, he used to be, in fact, he just cut super.
yeah, we're done.
Yeah, you'll know John,
Okay.
he's the one that's always there,
Okay, I'll probably go in there tomorrow.
and he tells terrible math jokes.
Okay, thank you.
Uh-huh.
I'm curious on how we got hybrid for the period.
For any of the graphs, you just divide by that b. For the
Yeah.
period. The base period on sine, cosine, and their inverses are 2 pi, so we do 2 pi over b. The base period on tangent and cotangent is pi, that's how often the asymptotes repeat. And so we just divide that by b.
Also, it's always gonna be pi over b for tangent cosine, and not
Tangent,
tangent
cosine.
cosine, but
Yeah,
how did we get the points?
we literally figured out sine and cosine. Figured out where the zeros are, anything that has a 1/0 is an asymptote,
And that's what took.
is a vertical dash line.
Oh, okay. A little bit. I'm kind of confused on the asymptote.
So 1/0.
Yeah.
Would be tangent. 1/0 happens at pi over 2. At pi over 2, we just make a vertical dash line. It's a line we don't cross.
Oh, okay.
Do you remember asymptotes from algebra?
Okay.
Like from algebra. This is such a white, we don't want to show what it's doing. Y equals 1/x. Had an asymptote for the y-axis and the x-axis. That look like this. They are lines you don't cross. That's what an asymptote is, you
Yeah.
approach it, but you don't cross it. Does
Oh, okay.
that make sense?
Yeah, that makes
The
sense.
approach, okay,
I think I get it.
okay.
Thank you.
Always fun going to the bathroom and someone's flushes every 15 fucking seconds. Dude, learn to zero water. Fuck,
Maybe they're courtesy questions.
Wait, no, it's okay.
every 15 seconds, it ain't expanding that fast.
It's sketched up when access. Yeah, sure.
You alright now? You're doing weird blinky shit.
My eyes are so itchy, I wanna scratch my corneas with my fingernails.
Yeah, I'm gonna recommend not doing that. I'm not an optometrist or a fucking eye
I know a good
specialist
doctor.
anyway, but I'm pretty sure that's not good. I thought, what would happen if I did this shit? Y'all make jokes.
I can't go and have a cool blast.
Alright, you guys ready? We're not doing any more than we were intending to finish last time, so we're gonna finish 6.2. We're gonna do 6.3. You're gonna have a fucking early day today.
Yes.
Actually,
That's the wrong fucking answer. It's just to say, why can't we go over, Mr. Jones?
Mr. Jones, why can't we like stay over?
You can, I have office hours from 7 to 7:30.
No, you have to say it.
You don't have to, you just have the option. Don't listen to Krista, she didn't know what else she's talking about. This is pretty standard.
Well, I mean, that's.
So let me hit record. Actually, let me hit stop.